Reshuffling Heat on a Warming Planet. Presented by Science at NASA. The ocean covers more than 70% of the Earth's surface. Reaching as far down as 36,000 feet in some places, the waters of our planet occupy a staggering volume. Enough, it seems, to hide a big mystery. For much of the past decade, a puzzle has confounded the climate science community. Nearly every measure of climate change, from the rising level of the seas to the mounting concentrations of CO2 in the atmosphere, show a warming world. Yet from about 2003 to 2012, global surface temperatures appear to level off in what some call the hiatus. The disconnect between rising levels of CO2 and warming surface air temperatures raised a question about where was the heat going. Scientists found a possible explanation. Extra heat was being stored in the oceans. Analysis by 3 ocean scientists at NASA's Jet Propulsion Laboratory not only showed that the extra heat could be going into the ocean, but also showed where. Basically, the missing heat has been hiding in a subsurface layer of the Pacific and Indian Oceans, says Veronica Nieves, lead author of a paper reporting the results, published in 2015 in the journal Science. Her co-authors were JPL's Josh Willis and Bill Patzert. The study included direct measurements of ocean temperatures from the Argo Array, a network of more than 3,500 automated sea probes. These probes dive deeper than a mile, take temperature, salinity, and depth measurements, and then return to the surface with their readings. Josh Willis describes them as the ocean's weather balloons. The warming they found showed up in a layer of water mostly between 100 and 200 meters below the sea surface. Nieves says, "Our analysis does not show any evidence of large amounts of heat below 300 meters." Bill Patzert says the subsurface heating gradually piled up in the western Pacific Ocean, then leaked into the Indian Ocean. This heat may not stay hidden for much longer, however. The temperature structure of the ocean is determined in part by a climactic cycle known as the Pacific Decadal Oscillation, or PDO. During its 20 to 30-year-long phases, the PDO shifts warmer and cooler waters around the Pacific Ocean, affecting how much heat can be absorbed from the atmosphere. Nieves says previous studies suggest a connection between the phases of the PDO and hiatus and acceleration periods. Lately, the PDO has been in a negative or cooling phase, but Nieves believes this is about to change. Right now, there are indications that the Pacific might be changing to a positive phase, which means that the warm waters that were hiding in the subsurface layers are re-emerging to the surface, she says. If warmer water gets to the surface, then presumably the atmosphere will respond. This could accelerate global surface warming sometime in the next decade or two. She adds, the planet as a whole has continued to warm steadily through time. Decadal variability is just modulating warming that has been caused by humans. NASA will continue observing the thermal state of the planet, looking at many factors, including surface and atmospheric temperatures, sea surface height, ice, and Earth's radiation budget. These factors and more will help people understand their role in an ever-changing world. For more news about climate, on Earth and other worlds, stay tuned to science.nasa.gov.